Chromatography. Alright, this is one of the most important topics in chemistry or science paper 2. So, this is God from the Academy. Don't forget to subscribe. So, the question is saying, this question actually came in 2020 science paper 2. So, it's saying, Elena carried out a chromatography experiment to identify components of substance X. So, we have this substance X, as you can see here. So, this Lena carried out the experiment to identify the components of substance what? X. So you understand that we use chromatography actually for this same case if you want to know the components of a certain substance. So water was used as a solvent. So they used water as a what? As a solvent. The results of the experiment are shown in the chromatogram below. So these are the results. Okay, so from here you can see we have substance X and we have unknown components A, B, C. We have the starting line. So this is the starting line of the points, these dots, the spots, and this is the solvent front. And we have these distances here. So the first question: which one of the unknown components A, B, or C is insoluble in water? The concept is simple. A, B, or C, which one is insoluble in water? For you to identify which one is insoluble, because they said they used water as a solvent, that's why they dissolved the experiment. So now, which one, A, B, or C, is insoluble in water? You look at the starting line. That component which has the dot on the starting line is the one which is insoluble in water, because whenever it dissolves in water, it has to move. The spots should move. Okay, like these ones, you've seen that they've moved, meaning these are dissolvable, they are soluble in water. But for this one, you see that it has this spot, this dot in the what? Starting line. It didn't move. It means it is insoluble in water. So A is what? Is insoluble in water. So for A, we are going to say A is insoluble in water. Then explain your answer. So for the explanation, you say because the spot did not move from the starting line, the spot remained on the starting line, so that shows that it is insoluble in water. Which of the unknown components was or were not contained in substance X? So this is substance X, and that's where we are taking reference from. We are referring to this. So for us to know which one was not contained in substance X, we are going to consider X. Then we'll look at the spot from X. You see that it came here, right? The dot came to this point here. So whatever the substance that was contained in X, it should move the same distance. Okay. Otherwise, if it moves any other distance, or if it didn't move any distance, it means it was not contained in substance X. So for the substance, for you to know that the substance was contained in X, it should what? It should move the same distance as this. So let's take a look at this. Let's start with B. You see that B has this point, this spot, which moved the same distance as this one from substance X, meaning B was contained in X because this moved the same distance from this one from X. So B was in substance X. What about C? Look at C. It ended here. It didn't move the same distance. So meaning C was not present in substance X. Even A, because A remained here. So that's the concept. For you to know that it was in X, it should move the same distance. It should reach this stage because that's where this substance reached. So A and C didn't reach this stage. Hence, they were not present. So A and C. For B, you say A and C. And the last question, calculate the RF value of component B. So when they say RF, they are talking about the retention factor. Retention factor. So you see that R is capital and the subscript F, small f here. So that's how we write it, the retention factor. So they said for what? Component B. Whenever you are dealing with the retention factor, RF value, retention factor value is equal to distance moved by the spot divided by the distance moved by the solvent. So this is the formula we use. So in this case, the spot is the one that they're asking about. They said component B. So the spot we are going to consider B, this one, because this is from B. So that's the distance from the spot. Then the distance from the solvent, this is the solvent front, they've indicated here. So this distance. And we always start from the what? The starting line. That's why it's here. That's why it's here. So our RF value is going to be the distance moved by the spot. Well, you just get your calculator here and then you check. This is the spot B. It ended here. Okay, here. So this distance from the starting line, this starting line, all the way to this stage, this line, because that's where B is. What's this distance? You understand that we've been given this total distance from the starting line to the solvent front as 28 centimeters. Then from here to this line is 7 centimeters rather. So for you to know this from here to this line, you get the entire line, the entire distance 28, then you subtract this 7 centimeters, you are going to remain with this distance, right? So here you are going to say, you will say 28 centimeters minus 7, we have 21. So meaning from here, the starting line to this point, we have 21 centimeters. So that's the distance for this spot from the starting line to where B is, 21 centimeters. Then the total distance, the distance moved by the solvent, so it's this total one, 28 centimeters. Then this centimeter cancels with this, so our retention factor is going to be 21 divided by 28 gives us 0.75. So it doesn't have SI units because they cancel since it's a ratio. So this is the answer. One thing you need to know whenever you are dealing with the retention factor, mainly the answer should be less than 1. It should be 0 point something, 0 point something. That's in most cases. So when you get the answer like this, probably you are right. So this was the question on chromatography. Hope you've understood it. Don't forget to subscribe.